record to this. Okay, so I'm going to start my screen share, and we're going to start the class as well. Okay. Okay, so I'm not going to move between screens today. So that's one good thing. I'm going to share my screen. Hopefully all of you are ready. Okay, let's start. Are you guys able to see my screen? I think you are. Why is this dot coming up? All right, okay. Okay, let's start. So, floating video controls, everything's hidden. All right. Okay, so in the last class, we learned about linear regression. We also did some of the maths for gradient descent. We did some coding. We learned about NumPy, pandas, and also at the end, I touched upon logistic regression. So I hope you guys remember all the things, or if you would have watched the video. So it's uploaded on YouTube. If you want, you can go and refer to that again. Okay, so in today's class, we're going to learn about KNN, we're going to learn about decision trees. So one point before we start learning is you guys should be using AI to learn faster. LLMs are really good at memorizing syntax. Humans are not. We're not supposed to remember syntax. We're not supposed to remember the code and stuff. We just need to understand the logic, okay? Earlier, I'm talking 5 years ago or 4 years ago, people used to, like, they had to remember all the syntax for PyTorch or TensorFlow. But in today's world, you don't really have to remember the syntax. You need to be able to understand what to prompt. And if you guys are already using Cursor, which is a really nice IDE, which is built on top of VS Code as well. So it's really good. And we're using AI to learn faster as well. So please use LLMs to understand any problem better, and you don't have to memorize syntax. So today we'll learn KNN, naive Bayes, decision trees, and random forest. These are all algorithms for supervised learning, and these are really simple. I'm going to try to break down all the concepts in a very simple and concise way. So if you guys have any question, please put it on the chat, and if someone knows the answer, please feel free to answer them. Okay, so moving forward, let's start with K nearest neighbors. So the first thing that comes to your mind when you think about KNN is, what does it do? It finds the K closest training examples in a data set. And when you have a new point, right, it's going to see which point is it closest to. Now, when I say closest to, what does it look for? It looks for Euclidean distance. Okay, so we've got the training examples. We've got, let's say, a few classes. Now a new data set, a new example comes up. Now the algorithm will tell you based on the distance of that data point to the closest class, and it will make a prediction. How does it do that? So if you see this, if K is equal to 3, it will consider these 3 data points. Now, if you consider these 3, there's 2 classes, class A and class B. Which one do you think this question mark will be? If you can answer quickly. So there's 2 examples of class B, one of A. So it will be class, the green triangle, class B, right? So if you consider K equal to 7 now, okay, K equal to 7 will be 4 versus 3. Now it will be class A, okay? So let's take a real example and let's go to the code directly in a bit. Okay, so there's 3 kinds of, this is a very popular example. If someone's done machine learning, you would definitely know this. This is very simple to understand. And I've taken this example from Code Basics channel. If you've already watched that video, so you might be familiar with it. So there's 3 type of flowers, Centosa, versicolor, and virginica. Now we're going to classify these based on certain features. What features are we going to take? For this example, let's keep it simple. Let's just take two features, uh, sepal width and sepal length. We can take more than two features. In the code, when I show you, we'll be taking maybe four features. Okay. So this is to make things simpler. I hope you guys are following till now. So on the x-axis, we've got sepal height in centimeter, and on the y-axis, we've got sepal width. So these three are different classes. The yellow ones, Centosa, the green ones, versicolor, and the blue ones, virginica. Now, let's say there's a new point. This yellow point comes up, and we'll calculate the Euclidean distance, and we take k equal to 3. So which one do you think will this particular yellow dot, this new example, will fall into? Any guesses? Blue, correct. Right, it will be virginica. Okay, so let's say if the value of k is 20, so we'll look at the nearest 20 examples. Now you can see that there's 7 virginica, there's 11 versicolor, so it will be versicolor. But this is not correct, right? Because when we look at the Euclidean distance, it's more likely to be in the blue class. And let's say if we know the ground truth, so we already know that the flower that we're trying to classify is virginica. So my model should be giving me the answer virginica. So if I take the value of k to be really high, this is gonna cause a problem. Okay, one thumb rule to take the value of k is root over n, where n is the number of data samples. So let's look at the Python code, and I'll share my screen again quickly. Okay, I hope you guys can see. I think yes, you are. So let's look at the code directly now. Okay, so I'm using, in the last class I've used Jupyter Notebook. Right now I'm using VS Code. So I'm also going to send a really nice video for you guys after this class, where you can set up VS Code for AI and machine learning, and you'll have all of the important extensions, and you can directly push your code to Git. So I would say that from the next class onwards, we're going to use VS Code, or we're going to use the proper format of using Python files instead of using Jupyter Notebooks. So Jupyter Notebooks are really good when it comes to research, but when you're building production grade applications, or when you want to deploy your applications, you want a nice folder structure. So if you have seen GitHub repos, you'll always see that there's going to be a really nice folder structure. So you can set it all up in VS Code, and you can start coding. So you can build software end to end using VS Code, not Jupyter Notebook. Okay, so let's start with this. I'm not going to run the code here. I'm just going to walk through the code. So we are importing the libraries. We're importing pandas. We're importing the iris dataset from sklearn, which is very popular. So this is the petal, and this is the sepal. Okay, so we are taking the height and the width of petal and sepal. So there's 4 features. Okay, feature name, sepal length, width, petal length, and width. Okay, and what are the target names? So we've got 3 targets, right? Very easy to understand, easy to follow through. So we are looking at a data frame. DF, we load the data frame iris data, and we'll see the head. So when you write dot head, it will automatically show the first 5 rows. So you can see that these values are in centimeter, and these are numerical values. Okay, so it looks good. Right now we have just taken column equal to feature names. Feature names have come in. We don't have the targets yet. Okay, let's look at the target. Now we look at df target. So we add another column called target, and that value will be iris target. Okay, so the target you can see here is all 0, which basically means, which basically represents what class. So 0 is Centosa, 1 is versicolor, and 2 is virginica. Okay, we usually give numerical values to it. So you can see that when you see the target equal to 1. So these are all the values of versicolor, and target equal to 2 will be virginica. Okay, are you guys following till here? So then we'll obviously add a column called flower name just to understand if we are doing the right thing or not. Okay, and then we'll check these random values between 45 to 55 row number, and we can see that some of them are centosa, some of them are versicolor, and that's the target. Target is 0. So our goal is to predict this target correctly. Okay, so what I'm going to do is I'm going to split this into 3 data frames. Okay, one is the first one will be 0 to 50, 50 to 100, and 100 to 150. Okay, so we're going to plot, and we'll see that we're only plotting sepal length and sepal width, because you cannot plot more than 3 actually, because if you go for 4, then it's very difficult to visualize that for humans. Okay, so we're going ahead. I'm going to skip through a lot of these things just to, in the interest of time. So we'll do the train test split. We have done this in the last class as well. For linear regression, it's the same thing. So train test split will be test size is 0.2, which means 20% of the data set will be used for testing. So how many samples am I training on? I'm training on 120 samples out of 150. Okay, so the X test is going to be 30. So we create a K nearest neighbor classifier. It's basically I've assigned the value as 10. So just to see how well it performs, we can see the accuracy or the score is 0.96, right? And we are going to give 4 values in it, and these 4 values are basically sepal width, sepal height, and then petal width, petal height. These are 4 values, and we're going to ask it to predict. So it's predicting 0, which is the first class. Okay, so we'll plot the confusion matrix. The confusion matrix looks like this. Let's plot it in a better way. 11, 12, 6. Now confusion matrix is very important when you're doing inference. Why? I've used confusion matrix a lot. This gives you a better idea of how well your model is performing. So on the left you'll see truth, and on the y-axis you'll see truth. On the x-axis you'll see predicted. So in truth you'll see that how many was 0, and it was predicted as 0. All of them are correct. So it's 11 out of 11. Same for predicted. So it's 12 out of 12. But for truth equal to 2, it was one of them was wrongly predicted as 1. That's why the accuracy was 0.96. So basically out of the 30 testing examples, how many were right? 29 was right, and one of them was wrong. Okay, so we'll print the classification report for precision recall and F1 score. I have one section, small section, where I'll go through what precision is, what recall is, and what accuracy is in that section. Okay, so one thing, I'll send you this link afterwards. You can use the link to go for an exercise. So are you guys following till here? Let me know. Can I see in the chats? Okay, perfect. All good. You guys liking the class till now? So we're done with KNN. Okay, let's quickly go to the next one. So chapter 2, we're coming to knife base. You guys will really like the example I've taken. Is it better now? Okay, so we're moving to the second chapter. This is knife base. Okay, this is really good because the example that I've taken here is really nice. We're going to do an example from NLP, which is natural language processing. Okay, so before we go to knife base, we need to understand what Bayes' theorem is. Bayes' theorem basically gives you an understanding of conditional probabilities, right? So you can find the probability of a cause given its effect. So you must have done this in your class earlier, which is P of A slash B. That's Bayes' theorem, right? So P of A slash B is equal to P of B slash A dot A divided by P of B. A, B are events. A slash B is probability of A given given that B is true, and probability of B given that A is true. And these two are independent probabilities. Please take a note of this word independent probabilities. I'll tell you why in the last ones we have done this, and the code as well. Okay, so this is one meme that I found and thought including this would be nice. So if you can understand this in terms of event, Netflix and chill, that was just one good meme. Okay, so we're gonna do the naive Bayes classifier now. We're going to learn the actual formula that's required for naive Bayes. So it's Gaussian because we assume that it's a normal distribution. Okay, so a normal distribution is like a bell curve. So that's why we call it the Gaussian naive Bayes. There's other type of naive Bayes classifier as well called multinomial and Bernoulli. I think Bernoulli is when you're predicting yes or no. So P of class slash data is P of data slash class into P of class. Now this is important. We don't calculate this in naive Bayes classifier. I'll give you the reason why in the next slide itself. This is really concise information. If you guys want to go into detail, if you guys want to go into more mathematics, please feel free to do so. But I'm going to explain this to you in a very concise manner. Okay, so understand this. If you want to take a screenshot, please do. So probability of an outcome given the evidence. So if you see the probability of evidence is same for all classes of Y. That's why we'll not be using that at all in the last one. So only we'll calculate this part, probability of likelihood of an evidence into prior probability. Now this might seem very confusing for you guys, that how do you calculate all these things? Let's take an example. Okay, so we're going to use the naive Bayes classifier to classify a little bit of, let's get directly into the code now. Okay, so this is the example that I have taken for you guys. This was from one of my courses that I did at IIT Gandhinagar during my masters for NLP. It's very simple, but it's just one pager, and we're going to do text classification using naive Bayes. Okay, so we're going to go through a data set and we're going to classify that. The data set is going to be of movie reviews. So it's an interesting one. It's not the boring ones that we usually use. So we're going to have 2000 rows of movie reviews, and out of that we're going to predict whether it's a positive review or a negative review. So a lot of people might know this. It's called sentiment analysis as well, right? So here we're just doing a simple classification because we have given the target class as binary. So either the review can be positive or the review can be negative. So this can be used in simple text classification algorithm to detect fake news, classify web pages, although you would not really see naive Bayes being used in production, but it's really fundamentally very simple because there is one reason why it's called naive, right? Because it assumes that all the features that you're using, right? So x1, x2, x3 dot xn. So there's n number of features. So it assumes that all features are independent of one another. That never happens in a real life situation. The features are dependent. That's what covariance is, right? Sorry, multicollinearity. That's one word that you use for the relationship between the features. Okay, in particular, you'll never find a situation where the features are not dependent on each other. But when you make this assumption, it simplifies a lot of things, and this becomes an effective baseline for supervised learning. So we'll build a simple binary classifier and we'll calculate the accuracy on classifying the movie reviews. Okay, so there's going to be 2000 rows, and we'll have categories as positive and negative. So if you have any questions, please write them in the chat, and I can it be used in semantic and yes, semantic analysis? Yes, it can be. So it's a simple classifier, right? So basically, when you have any data, and if you want to predict certain classes, right? Let's say 0 or 1, positive, negative, or it could be 5 classes, 6 classes. You can use these algorithms. But now you might be asking, like, how do you know which one works better? You really have to try all the algorithms. You might have to use an ensemble method as well. So let's look at this example. This is a good one. So uh, I'm printing some of the information about the corpus. So in NLP, the entire text thing is called a corpus. Okay. Um, Let me see if this is Discord. I'm guessing this is Discord that is pinging. Yeah. Sorry about that. Okay. Um, Yeah, so I'm printing some information about the data set. These are the labels, which is negative, positive, and the number of negative. So this is a perfectly balanced uh, data set. In real life, you'll never really see such. Uh, yeah, thanks, Akansha. Yeah, the flip phone. So you'll never really see such a data set. You'll never really find a data set which has like 1,000 positive, 1,000 negative, right? But this is a perfectly balanced one. Okay, so I'm doing some analysis on this. So basically, this is where it gets a little interesting because this is a tuple, right? So in the tuple, we've got the movie review. Now this movie review is broken down into tokens. Okay, each token is basically the comma, apostrophe s. Everything is broken down into this single entity. Dot is also a token. So all of this is token, and then the second parameter in the tuple is the class that it belongs to. So it says that this is a negative comment. Okay, so we'll extract the features which will help us classify text into two categories. So here I'm just extracting the features, and I'm printing the 15 most commonly occurring words. So these are some analysis, or these are some things that you would do with a text based data set when you're using NLP techniques, right? This is sort of using naive Bayes in NLP. Okay, so I can see that the most number of words, most number of times the word film has been used. These ones have been used most number of times. Okay, so these are most common words. So I'm doing some sort of EDA, and also doing a little bit of pre-processing, and I'm trying to see contains film, true, contains true. So I will basically define whether this particular review contains all these words or not. Okay, and then this will be my feature set. So we'll create a separate training set and a testing and validation set as well. So it's the same thing that we did. I'm gonna quickly skip through this. So you can see out of 2000, we have selected 1600 for training, and we're gonna test on 400. So I've used a knife-based classifier from sklearn directly, and the classifier accuracy was almost 80%, which is not that great. So 80% of the time, it's correctly classifying it as a negative or positive review. But we are here to look at the math behind it, okay? So now let's say if you want to predict something, you've trained your classifier, now you want to predict something. So it's very simple to understand. So let's say if I write a sentence, I hated the poor acting. Now that you have to use this particular formula which we saw in the previous slide. So it will calculate the probabilities of each of these words or each of these tokens based on uh, the fact that it's a positive or not. So the probability of this will be really, really less compared to the probability of being a negative one. So you see 10 power minus 5 is greater. So this shows that this particular uh, sentence belongs to the negative category. So I hope you guys are able to follow this part. That it's a very simple argmax basically means that we're taking the maximum value, and the maximum value will be from the negative class. Okay. So I did the same thing, and maximum probability was negative, and I can see the probability of being negative was 0.999999, and the probability of being positive was very less, exponential minus 10. Okay. So these are some of the references I used. I will be uploading this particular notebook in my GitHub repo, in which you can see. Okay, I hope you guys are following me till here. Let me check the chat. Okay. Right, let's move on. So this is a simple one-pager summary of what the entire naive Bayes theorem is all about. Okay. This is a Bayes theorem. This is the predictor template. X is the features that we've taken. This is a probability of, so we calculate all the probabilities. We take the argmax. Then we have the naive hypothesis for simpler likelihood, which we just did, right? Easy to estimate. We completely nullified the denominator. And then we are estimating the Gaussian parameters. Okay, so if you see this, this is basically checking what is the probability of that happening, and we predict the class to a new sample. Looks fancy, but we learned naive Bayes with a very simple example. The algorithm is called naive because obviously you should remember this if you're giving an interview, or if you ever asked, you should know that it's called naive because it assumes that the presence of particular feature is unrelated to the other one. Okay, let's move on to chapter 3, evaluation metrics. As I said that I'll be showing you this one. So this is very important. When you are training a machine learning model, you should know how to evaluate that model as well. Now when I say evaluate, you need to understand that there are some metrics like accuracy, precision, recall, F1 score, or when it's regression, it's RMSE, MAE, mean absolute error. So these are metrics with which we can understand how well a model is performing. Now this is for classification. So we'll try to understand what TP, FP these mean. So does anyone know what these mean? Can I see in the, I hope there's no gray box now. Is there any gray box? I have no idea why this is coming up. Yeah, I think it's gone now. Yeah, thanks. Right. Okay. That's right, Anjali. So it's true, negative, true, positive. I think you guys already know. Cool. I'll just show you a really nice example for accuracy. So out of all the predictions that we did, what are the correct predictions? So this is accuracy. A lot of people don't understand this because they get very confused. अच्छा prediction, precision और accuracy में difference क्या है? ये difference है. So precision is when you compare the positive predictions with the correct prediction. So there's positive predictions and there's negative predictions. So how many classes were predicted as positive, and how many out of them, how many were correct? So you can see out of the 6, only 3 are correct. So to understand recall is basically out of the predicted results. Basically we'll add true positive and false negative as well into recall. So in precision, we are checking the number of true positives in the actual results. Okay. So simple to understand. These are some of the formulas that you use for F1 score. This is particular metric. So I hope you guys are clear. This is very simple, and we'll move to decision trees and random forest now. So I'm glad that this class is going really well because I've not kept a lot of content for this class. Um, this is going to be over in a few, maybe 15-20 minutes, and then we can discuss and also talk about other things in AI, right? And how we can progress. So let's learn about decision trees. Now, when you want to go and buy a car, this is one example. You'll certainly think about what's the price of the car, what's the color, is the model new or old. Let's say you're going to buy a second-hand car. Now, what is the mileage of that? What's the brand of that? So based on that, you will take a decision. So this is what a decision tree is for. Okay. So we can calculate these parameters based on two things. One is called entropy or information gain. The other one is called Gini impurity or Gini index. Now I'm going to use Gini index for this example. Gini impurity basically means like the less number of Gini impurity, the less value of the Gini impurity, that particular uh, feature or that particular node is taken. Okay, so if you see that, we'll also use one example to calculate Gini impurity. I used AI, as I said that whenever you don't understand a particular topic, use AI to understand it. So I also typed in AI that can you give me an example for decision trees, and it gave me a simple example. So we are using Gini index. I can actually show it in my iPad as well, but I wanted to, in the interest of time and to keep things simple, you can probably understand that student based how many yeses, how many nos. So based on this, Gini index is calculated. So Gini impurity of student, the entire thing is 0.367. Gini index of credit rating is 0.429. Income is 0.44 and age is 0.34. So which is the best one? Age. So we're going to go ahead with age, and then we're going to decide on our decision based on that. So that's for one particular node. That's how we'll keep going until we figure out the last one. So this is going to be much simpler once we go into the code. Okay, but I wanted to take an example, and this is from ChatGPT. So we have one feature called Outlook, and it has three categories, right? Sunny, overcast, rainy. So if you saw that, these are all the features. So Outlook is one of them. So here you'll see that in income we've got three features: three values: high, medium, and low. Now you're gonna predict, you're gonna calculate Gini impurity, and it measures the probability of misclassifying a randomly chosen element. Okay, so it's equal to 1 minus probability of a particular class in a node. So in a particular node, you will have a particular class. So I'm gonna directly show you the breakdown of the data set. So there's 14 examples. So all of them are Outlook. In Outlook, you have sunny, overcast, and rainy. Okay, so these are 5, 4, and 5 samples. So 2 of them are yes, 3 of them are no. So what do you mean by yes and no? So yes basically means so this was one example for predicting whether you will play or not. So if yes, then it means that you go to play. If no, then you don't go to play. So step-by-step calculation of Gini impurity. So you'll see that one particular, for sunny, you will calculate based on 5 samples, and the probability of yes is 2 by 5, probability of no is 3 by 5. And then we'll calculate the Gini for that, because we have to calculate the probability of positive and the probability of negative and subtracted by 1. So 2 by 5 and 3 by 5. So we do the square, and we get the value of 0.48. Similarly, we'll do for overcast and rainy, right? So we did for overcast was 0, rainy was 0.48. 4, 8. So which one do you think will be selected? It will be overcast because Guinea impurity, the lowest one, the purest node is selected. And it's the opposite for information gain. Information gain, we use a different formula, but we choose the one with highest number of information gain. Okay. Once we have calculated the Guinea for each of these values, then we're going to calculate something called as weighted Guinea. So how are we doing that? So how many samples did we have for sunny? We had 5 samples, right? 5 samples. Overcast, we had 4 samples. Rainy, we had 5 samples. So total there were 14. So we're going to have 5 for sunny. We're going to have 4 for overcast and 5 for Guinea. This is a weighted Guinea, and we're going to multiply that with the Guinea of that particular class. So this is how the weighted Guinea was calculated. Okay, so this weighted Guinea was the average of all the values that it could have for outlook feature, right? So this is a weighted Guinea. As you can see that these 3 values amount to this much, and total weighted Guinea was 0.3428. So this was just to calculate the Guinea impurity of the feature outlook, right? So I hope you guys were clear, and if you have any questions in this, it's a very simple explanation. Okay, perfect. So let's talk about random forest as well while we're at it. And then we can look at the code directly for decision trees and random forest. Okay, random forest is basically an ensemble of multiple decision trees. Now, it's very simple to understand. It's like a decision trees, but we use multiple decision trees here. There's 2 methods called bagging and boosting that we use in random forest. So each tree in the random forest is trained on a different subset of the data. So if we take different subsets from the data, it will improve the accuracy. It will reduce overfitting. So do you guys know what overfitting is? Overfitting is basically when the model is performing so well on training data that it learns all the training examples by heart. Or for example, if you have all the x's in a particular fashion, the line that's fitting it will exactly cross through all the training examples. Now, if that's called overfitting. So similarly, we have underfitting and then the generalized model. So we need to make sure that there's no overfitting in the model, and in a single decision tree there might be, which is because of noise. But when we use a random forest, it will average out the predictions. Okay. So I'm gonna show you what bagging and boosting looks like. But just understand that in bagging, we have multiple trees which are trained on different bootstrap samples. Okay. And in boosting, we have sequential building trees, right? So the tree tries to correct the errors of the previous one by improving the overall prediction performance. So I'll show you what bagging looks like. So these are different subsets and different models are built on top of it, and then we've got a combined prediction on it. And this is a better example to show difference between bagging and boosting. In boosting, we have the sequential data where the error of the previous one is corrected by the next one. Okay, and this is how a random forest classifier would look. We have the entire data set. It's split into different decision trees. This is decision tree number 1, 2, 3. There can be multiple. Okay, so this decision tree, let's say this is a prediction, and for this one is a prediction. So all of this prediction are averaged and a majority vote is taken. Now based on that majority vote, the final prediction is made. So it's understandable, right, that if the most number of decision trees are giving the right answer, then random forest is going to be a better classifier than decision trees, because we're using multiple decision trees, and it's likely that most of them will give the right answer and some of them will give the wrong answer. But when we're averaging it out, the predictions are better and more accurate. So most of the time you'd see that a random forest has much better accuracies than a decision tree. Okay, we'll look at the code now. So I hope you guys have followed the things which I showed. So I'm going to show you a simple example here, and I've also created one for this, which is from synthetic data. I think I remember showing you this example in the very first class when we were doing basics of AI and ML. So you might remember this. So that's why I've taken a different example. This code is already available. So we've got the data, we've got study hours, we've got attendance. These two are features, and this is the class that we want to predict, right? So we build a simple data frame, then we define the features and the target. Okay, so we define the classifier, we fit the model, and then we make predictions. So it's in a very simple and concise manner, and then it shows you the Guinea impurity and the class of that particular value. So this is very easy. I've already showed you this example. If you want to see a better example, then we've got the outlook, which was sunny, overcast, rainy, and then we've got temperature, then we've got play, yes and no. So we want to predict whether we're going to play if it's sunny, or based on the temperature if it's hot. So which one is a better feature to predict play? So that's with something called, we can find that out with something called as feature importance. We use feature importance for random forest. So I'll show you the code's very simple, because we have to map these text values to numerical values. So we put sunny as 0, overcast as 1, rainy as 2, same for temperature. And then we also want to put the play to map the play to yes and no. So the 0 class means no, and the 1 class means yes. Okay, and we also have to split our x and y. So we're going to use x, which is features x1, x2, and predict y. Okay, so this is a very simple decision tree that you can see, pretty intuitive. I've already walked you through the samples and the values and how I've used Guinea here. So I think, yep, you can define your criteria that you want to use. I've used Guinea. So this is how the decision tree will look. And if I want to build a random forest, I can do that and also check the feature importance based on that. So when I calculate the feature importance, it's coming out to be 0.6 for outlook, and for temperature it's 0.39. Okay, so this is one example, and the other one is from a real data set, or not too complicated. It's also very simple. So we have got different company, we've got the job, we've got bachelor's, master's, the degree, and if salary is more than 100K or not. Okay, so if it's 0, that means it's not. If it's 1, that means it is. So we want to predict what will be the value of salary more than 100K, if it's going to be true or not, based on the features given here: company, job, and degree. So we're going to pre-process the data. We're going to use label encoder to define these things, the same thing that we did in the previous example, right? And then we're going to check what the inputs are, and then we have the targets here, same thing, and we're going to use the model to predict. So if we give these three values, 2, 1, 1, so you can go to the label encoder and you can see which one's 2. So you can see Google. 1 is basically computer programmer, and one is basically masters. So what is the chance of that having uh, a salary more than 100K or not? Our model is going to simply predict a 1, I guess. Yeah, this is the prediction. So uh, that's the gist of decision trees and random forest. And I will send you these two exercises as well. So there's one which code basics they have given for Titanic dataset, and you can go through this one to practice um, decision trees and also KNN. So I am gonna stop sharing now, and also I'm open to questions. Please let me know if you guys didn't understand something or if you want to discuss.